All right. So MC is going to talk about testing maternal contributions in Triploid Eastern oysters, and this is a field evaluation in coastal Alabama. We're a little behind, so 9:48. Yeah.
That's
all right.
totally fine.
All right. Then there you go. All right.
Okay.
That gets you forward.
Good morning. I'm Mary Collier at Eastburn. I'm the hatchery manager at L3 Hatchery and Battery, and I'm one of Bill's previous graduate students. And today I'm going to present my master's research and results that focused on maternal contribution and triploid oysters. So, as most of us know, triploid oysters have become the mainstay in off-bottom oyster aquaculture because they've shown increased meat quality during summer months, potentially faster growth than diploids, and possible resistance to spawning season mortality. And commercial hatcheries have been able to produce their own triploid seed because of the advancements of triploid induction techniques and technology, like the development of tetraploid broodstock. This table just kind of describes commercial triploid numbers from AUSL their last year in the commercial industry, and then Hooper Island and Cherrystone from 2017 to 2020, which just highlights the importance of triploid seed in the industry. However, as this industry does expand, there have been reported challenges with the triploid oysters, specifically summer mortalities. It's been well documented globally and has been reported to occur in other species like Crassostrea gigas. The cause of these mortality events has been speculated to be a combination of rising temperatures and decreasing salinity during early summer months. And this is when the oysters are potentially more vulnerable when they're preparing and developing their gametes for spawning season. A unique aspect of the reported mortality events is that there was no single cause linked to disease or extreme environment. And some Chesapeake Bay farmers reported up to 85% of crop loss. And there were previous studies by Wadsworth and Bodenstein that explored the idea that maybe site or farm handling techniques could affect triploid mortality. However, they found that despite site or farm handling technique, triploids did experience higher cumulative mortality than diploids. So then selective breeding has been explored as a solution to these triploid sensitivities. Callum reported that triploid performance was affected by maternal contribution, but Matt found that despite the paternal contribution from distinctly different lineages of tetraploid broodstocks, the oyster's performance was not significantly different. So with all these findings in mind, we set out a goal to increase triploid performance in the northern Gulf of Mexico by using wild broodstock that was harvested from 3 historically different sites in Louisiana. We explored whether maternal contribution of these wild oysters would affect the triploid offspring's performance. Additionally, we had reports from farmers saying that their larger oysters were dying versus their smaller ones, and so we asked if we broke these into size categories, would this affect their performance, as specifically in triploids. So for our study, we got wild broodstock from 3 different sites in Louisiana: Sister Lake, which is historically known to be low salinity; Calcasieu Lake, which is known to have high salinity; and Vermilion Bay, which is known to have a pretty variable salinity range. In mid to late July of 2019, 6 groups of half-siblings were spawned and later deployed in November when they were about 4 months old. So the first study was conducted at 3 sites in coastal Alabama that had historically different salinity ranges to mimic the sites that the broodstock was selected from. Our low salinity site was the Bama Bay Oyster Company in Mobile Bay. Dolphin Island at Massacre Island Oyster Ranch was our high salinity site, and then the AUSL Research Farm at Grand Bay Oyster Park in Grand Bay, Alabama was our variable site. For our second study, the size impact study, we used Sister Lake and Calcasieu Lake oysters, and we mechanically graded them into size categories: small, medium, and large, as a proxy for growth. And these treatments were deployed in March 2020 at the Grand Bay site. Both experiments were deployed in floating cage systems. For data collection, we used hobo monitors for daily environmental data, and monthly we monitored mortality and growth, and quarterly we conducted condition index and dermo disease infection intensities. But for today, I'm just going to stick with the growth, mortality, and condition. It is important to know that we did not impose any additional stressors on these experimental groups, such as desiccation or tumbling. We just changed the bags out monthly. This is how I calculate interval mortality and cumulative mortality, and for growth rate, we used the shell height, which was from the hinge of the oyster to its longest point on the bill. For the results, I'm just going to break it up by study so there's no confusion. With our broodstock origin study, we did experience 100% mortality by June of 2020, so that data is limited to that time interval. And because we expected differences in respect to each study site, we did not include site as an effect in our statistical model. So, important part of this environmental data is to note from March to April, there was a decrease in salinity while the temperature had a steady incline, and this is important, especially for our Mobile Bay site. So for cumulative mortality, despite the broodstock origins, triploids had significantly higher cumulative mortality than diploids at all 3 sites. This graph is a lot, but in March to April, during that time interval when salinity was decreasing while temperature was increasing, all 3 sites had a spike of mortality, but the triploids did experience significantly higher mortality than diploids. There is a later spike in mortality at Dauphin Island and Grand Bay from August to September, but we did not find a significant effect of ploidy or broodstock. So I broke down the Mobile Bay growth trends just so you can see prior to the extreme mortality event that the sister lake oysters had a clear growth advantage, not only to its diploid half-siblings, but to all other treatments. Our analysis did include growth rates through the end of April because of triploid, sister lake, and Calcasieu Lake experienced 100% mortality by June. There was no significant difference between diploid and triploid growth rates. However, the sister lake had significantly higher growth rates than Vermilion Bay, but we did not find any other differences between broodstock origins. At Dauphin Island, sister lake and Vermilion Bay triploids grew significantly faster than diploid counterparts, as well as the high salinity Calcasieu Lake oysters did not differ from each other. At Grand Bay, despite the ploidy, sister lake oysters grew significantly faster than the Calcasieu Lake and Vermilion Bay. So at Mobile Bay, condition actually increased, but we believe this was due to stress triggering the animals to use their energy for more growth and gametogenesis. Expectedly, at Dauphin Island and Grand Bay, the condition did decrease, with triploids at Dauphin Island in September had significantly higher condition than the diploids, which was also true for Grand Bay in June and September. The sister lake low salinity progenies had significantly higher condition index than Calcasieu Lake, but the Vermilion Bay did not differ from either. So this just further provides evidence that triploids do have an advantage in terms of meat quality. For our second study, our size impact study, we analyzed performance based on size and ploidy and did not include broodstock as an effect in our statistical model. So for sister lake oysters, the large oysters experienced significantly higher cumulative mortality than both medium and small sized oysters. Additionally, the triploids did experience higher mortality than the diploids. For Calcasieu Lake, this was not necessarily the case. We did not find any significant effect of size in terms of cumulative mortality, but once again, the triploids did have significantly higher cumulative mortality than diploids. From April to May, we did observe a spike in interval mortality in the sister lake oysters, and upon further analysis, we found that interactive effect of ploidy size on this mortality. The large diploids experienced the highest mortality during the interval, while the small diploids experienced the lowest. For Calcasieu Lake oysters, there was no significant difference in mortality with respect to oyster size during April to May, but the triploids did experience a higher mortality. In terms of growth, the sister lake oysters grew significantly, small sister lake oysters grew significantly faster than medium size, which in turn grew faster than large size oysters. And then in the Calcasieu Lake oysters, the triploid small size oysters grew significantly faster than all other treatments, while the diploid largest grew the slowest. I forgot what I was going to say. We're going to move on. We're going to go past that. Okay. Okay. So for condition index in November, at the end of the study, the Sister Lake and Calcasieu Lake oysters were significantly impacted by size, regardless of their ploidy. Small-sized Sister Lake oysters had significantly higher condition index than both medium and large-sized oysters, and then the mediums, in turn, had significantly higher condition index than the largest. Similarly, we did see that the small-sized Calcasieu Lake oysters had significantly higher condition index, but the medium and largest did not differ between each other. So to wrap this all up, we did not find a significant impact of broodstock origin on triploid mortality. However, it may be seen in aspects of performance like growth. Overall, the triploids experienced higher mortality regardless of broodstock origin. The size category effect on mortality could depend on the selected line of oysters. And the severity of this mortality seemed to be site-dependent based on our results from the Mobile Bay site. When it comes to selecting lines, there could be a potential improvement there. However, further research is needed to determine the best population for this selection. And then lastly, I just want to add, after a year of having the industry under my belt, I do believe that farmers should recognize the trade-offs of growing diploids versus triploids, and understanding their vulnerability during these late spring, early summer months to reduce that. And because our experiments did not have any imposed stressors, this might be something to evaluate. In my personal experience with farmers, some of these practices have been reported to help counter the chance of that extreme mortality. So with all that, I would like to thank AUSL, the LSU Food and Science Lab, Sea Grant for the funding, and Bama Bay Oyster Company and Massacre Island Oyster Company for allowing me to do this research.
Great job. Any questions for MC? She wants to go away before anybody asks a question. So, anybody have any questions for MC? What was the density per bag?
So for our first study, we did 50 on each side. We used divided 9mm Vexar bags, and we had 50 on each side. However, for our other study, we had 80 on each side because we had 12 experimental treatments for the second study. We had kind of space constraints. So for the first study, one bag was a whole replicate, but in the second study, one side of the bag was one replicate, so we put more oysters on one side in the second study. Does that help? Did I answer that?
All right. Thank you, MC.